For solving quadratics, pretty much the same. Notice here what I can do, x squared plus 9 won't factor because it's not a difference of squares as far as a real one. So what I can do is just set it equal to 0 since I only have two terms. And subtract 9 from both sides. When I do that, I get x squared equals negative 9. To get rid of the square, take the square root, but when I take the square root, I got to make sure I do plus or minus. So now I have x equals plus or minus the square root of negative 9. Pull out the I, and I get x equals plus or minus I, and I get square root of 9. Well, square root of 9 is 3, and so I'm left with x equals plus or minus 3i. For b, try to factor it. Is there anything that multiplies to give you 15 but adds to give you 6? Nothing works. All you have is 5 and 3 and 1 and 15. So use the quadratic formula. When I use the quadratic formula, remember it is, so there's our quadratic formula. I'm just going to plug in the parts. So here's my A, here's my B, here's my C. So I get a negative 6 plus or minus the square root b squared, so I get 6 squared minus 4 times a, which is 1, times c, which is 15, over 2 times 1. Clean up the top. I get negative 6 plus or minus the square root of 36 minus 60 over 2. I get negative 6 plus or minus the square root of negative 24 over 2. And from here, see, negative 24, pull out the I, but you can pull out 24 and make it a 2i with the square root of 6. 2 times 4, or 2 squared is 4, 4 times 6 is 24. So the biggest factor you can pull out of 24 is 2. And because the 24 was a negative underneath the square root, that's why we have the I there. Over 2. And the last part now is just to simplify it down. I get a negative 3 over, well, I get a negative 6 over 2 plus or minus 2i, supposed to be an I, times the square root of 6 over 2. And my final answer would be negative 3 plus or minus 2's cancel here, and I get I times the square root of 6.